Welcome to the Lit Media Workshop. This is Internet Part 2. Today we're going to learn about more about the Internet, the structure of the Internet, searching the Internet. We'll even do a little bit of coding. So I hope you are as excited as I am to do this. All right. So here's our overview here. We're going to be talking about different kinds of ways you might structure things on the internet. We're going to talk about the World Wide Web, things like web crawlers and search, as well as surfing, some different kind of items here. In terms of homework, if you haven't done it yet, watch that old video. You can Google it on YouTube by typing the Kid's Guide to the Internet, like 90s. I'll put it in the description again. Hopefully you've taken home your Morse code practice thing. You don't really need to bring that back. But you do need to bring back your Wikipedia surfing assignment if you were able to do it, and that's going to be part of our discussion. Just as a reminder, in this class we're learning how to do things like read and create, and appreciate all of the different kinds of digital media that are a part of this class. And today we're going to be looking at both the microscopic little elements that make up HTML, and we'll even talk a little about the macroscopic big picture that makes up the internet here. And before I even talk about that, I want to talk a little about escaping past metaphors. Basically, when the internet got created, and when anything new gets created, it's kind of difficult to let go of something that's been familiar. This includes creating a web structure rather than being something more familiar. So for example, we used to have cars that looked like this that had a tiller, which was much more easy to move around this way and was something you might be used to if you were driving a boat. Now, we also had something called a telephone book. And the telephone book used to just have an alphabetical listing of people's addresses and their telephone numbers. We used to get one called the Yellow Book that would include advertisements and things like that at my own house. And they used to be even more prolific. On the right side here, you will see the Encyclopedia Britannica. There's been encyclopedias across different cultures for a very long time, and they're normally used to basically represent all of human knowledge, which it's very, very funny to think that you could represent the most important human knowledge on just one tiny bookshelf. Nowadays, we have counterparts for these. We have a steering wheel. This is a different thing that you drive, and it's more intuitive for driving a car, although I don't know. Anyway. And then we don't actually have to memorize phone numbers. We have something called contacts. There are apps in our phones, there are apps on our computers, they're synced up, and they just kind of take care of themselves. And I don't really know anybody who has encyclopedias at home. Instead, you might use something like Wikipedia, which has much more information than a single bookshelf could hold, at least if you use paper. So we talked about surfing the net a little bit last time, and if you watch that cool 90s video, you have some idea about what's going on here. This picture is from Tim Berners-Lee, the actual inventor of the internet, while he may not actually take that as a claim. And basically, the internet came about as part of his work at a physics lab called CERN. And in this physics lab, he thought, oh man, there's all these different kinds of components that I could just connect together and it could make this cool thing called the World Wide Web. And he planted a flag in the ground and decided to try to push that forward. And eventually, I think it ended up very well. So this paper is from 1990. And there's issues in just structuring data itself. Information is complicated. If you don't have that much data, you might be able to put it into something like a database, and that might be just fine. So, the issue here isn't really when you have just a little bit of data. Make that a little bit bigger. It's not when you have just a little bit of data that you really end up having problems. When you have a little bit of data, your problems are pretty small, but the more data you have, the worse your problems kind of become, especially because the bigger your data becomes, the less it belongs only to you. And so something that Tim Berners-Lee talks a lot about is like this mesh. A mesh, like a web, like a connected thing together where I can take care of my stuff, you can take care of your stuff, I'll have my website, you have your website, and we don't have to change each other's websites. We can just be responsible for our own thing. And so these problems in data come both from how wide your data is, like how much content is on a single page, and then how deep it is, how many different web pages there are on the internet, and then how complex they are. What are the links between a particular set of web pages? Is it complex? Is it simple? Is it just a little tiny loop? And so let's look again. We talked a lot about networks already, but we'll talk about it yet again. And we'll talk about that in terms of actual people, like people. And this is what Tim Berners-Lee says on his paper here. This is actually from his website that's directed towards kids. He said, I didn't invent the hypertext link either. The idea of jumping from one document to another had been thought about already. If we have time, we'll go over Vannevar Bush. And other people had made systems before him, such as Doug Engelbart, which were hypertext things, but they just ran on a big computer. They weren't networked up together. But instead, he took the hypertext idea and connected it to some of the communications things, this TCP and this DNS application, which was already becoming a thing with the bulletin board systems and networks that you would connect to remotely that just were not accessible to everyone. So when we talk about people, he said, we can call the circles nodes and the arrows links. We've seen this before. Suppose each node is like a small circle, and each link is like a string, basically an arrow, a directed arrow between these different nodes. This is the basic premise of the internet. And so he's talking about what if we could just have something that could be anything? It could represent people. It could represent some kind of software modules, things that you would use for software engineering and writing software. It could represent groups of people or projects or concepts or documents or types of hardware or specific hardware objects. What if you could just have one kind of thing that can represent any of these things and, make references to them? So he talks about all the different ways you might represent these. In the diagram, you might have a family tree where the people are nodes and an arrow means is the parent of. And so I won't read every single one of these, but you get the idea. The system must allow for any sort of information to be entered. This is what Tim Berners-Lee says. They must be able to find the information sometimes without even knowing what they're looking for. And this is really this whole idea of surfing, where if I can kind of think about something close to where I'm getting to, maybe I'll find the right thing as a link there. Okay, and I really liked this part in his paper as I was rereading it. He said, let's imagine that we have all the people at CERN. There's so much turnover. Nobody knows whose job it is. Everyone's going to be here for just a couple of years. So imagine making a large three-dimensional model with people represented by little spheres and strings between the people who have something in common at work. Now imagine picking up the structure and shaking it until you can make sense of the tangle. So I'm going to use a little demo here from the internet. And this is some kind of technology that didn't exist at the time, but we get to have a look at it. Okay, so these are characters from a book called Les Miserables. And in this book, there's all kinds of people. The person who the book is arguably about is Jean Valjean. This network is all connected together, and we can just stretch it, we can shake it, and we can try to make sense of it. Okay, so Jean Valjean is connected to a bunch of people. In this green part here, we have Javert. And Javert is kind of like the nemesis. And, you know, all of these people are linked up and you could represent them as hypertext. And I just think it's like interesting to think about this whole structure, which is actually 3D, represents very complex data. Data that's much more complex than just a simple list or a tree of information. And it comes with its own difficulties, which is mainly that it's just so complex. I'll include a link of this in the description in case you want to dig further. Okay, so this is also an image from the paper. It talks about how it actually works, where you might have several different kinds of systems running at the same time. And some of these things are called browsers. So this browser, you might be familiar with Chrome or Internet Explorer or Apple's Safari. You might have a single client that's trying to connect to a server that has hypertext, and this hypertext server may have information that it's even getting from other servers. And you might have another client connected to this other server. And so we want to be able to relay that information. And that's the gist of it here. Now, what is hypertext? We talked about this a little bit in class, but hypertext is basically the ability to have something that's active. So hyper means it's directed. It uses directed links to surf on things. So you can actually click a link and go from one place to another place, just like you should have done, hopefully, on Wikipedia. Text is, of course, just text, like writing and different kinds of media that might be on there. And Lee is very sure to talk about, well, you could have images, you could have videos in the future, but we don't really have that right now. Then we have markup, right? Markup is basically things that you can add to it. And then we have language. So markup language together basically is like a very small kind of meta language for programming something that looks visual. And so it's much, much, much less difficult to program something like this than to, say, program a video game at the time. And to look at a good example of what some of this HTML looks like, we're going to take a look at Tim Berners-Lee's actual website. So this is his page where he talks about answers for young people. And if you click on one of these links, it takes you to that spot on that particular web page. On most modern browsers, you can right click. This is Chrome. And you can look at something and say view page source. Well, there we go. This is the code that's actually there in his website. And it starts with something that we don't really have to think about right now. This says HTML, and we go all the way back down to the end, and it finishes with HTML as well. And if we wanted to find a piece that was actually on his page, we could look at these things side by side. So for example, if we wanted to look and see where it says, where were you when you invented the www, we could look for where were you? And this appears in a couple of places. It appears here as a link using this begin list item, HTML tag markup. And if I hit next, then this is where this A tag has an ID, and it includes this document here. So this part is text. I was working in a physics laboratory called CERN. And then CERN appears here, and then the rest of the text appears after that. So the text has some kind of magical tagline things associated with it, which I will go over in just a tiny bit of detail during this class. You can do this with every web page, but and I recommend that you try it. If you try it out on a different web page, it's probably going to look kind of yucky compared to how the actual text looks here. There's another small thing that I bet if you looked at every individual line, none would go over 80 characters. This is a programmer convention. This person is old school cool. We're going to continue on these slides. And we're going to talk a little bit about files. What is a file? Well, I don't really have any good files here with me, but basically a file would be like a piece of paper that you would put in a folder. We're going to pause. And, so this file thing, it is basically just a way that you represent something. It's kind of hypertext-y, except the links are not always there in the same way. You have lots of different files on your computer, and I will show you some on my computer. For example, over here, this is part of my Lit Media Workshop folder that exists on my computer, and it has this thing at the top, which is kind of like a URL, like how you would access that information. I can actually just right-click here and say New Text Document, and I could call it something like this is, or just whatever, test.html. And I'll just ignore this warning because I know what I'm doing. And then I could take this test.html and we could look at what's inside of it. Should we see what's inside of it? It is nothing. There's nothing inside of it. If I view the source, it might have added something, but I'm pretty sure it'll just be basically blank. There it is, it's blank. Now, if I actually wanted to open up this file, I could right-click on it, I could say open with, and I could say something like edit in Notepad. And if I do that, okay, so that opens up test.html, and I could begin to do things like just write down my own HTML right here. And I'm going to do this a little bit in not an elegant way, just to kind of show you that this works. I might have HTML here, I might have a body tag here, and something to note is that all of these tags, they have a beginning and they have an end, and then you can put them inside of each other. That's called nesting. So in this body tag, I'm going to include a header that says big text. And then I'm going to have a paragraph, like a P like this, that says little text. And then if I save this file, I can hit File Save. And now this file is on my computer. If I right click on this file and I hit Properties, it will tell me exactly where this file is on my computer. And it is right here. Now, if I hit refresh here, let's see what happens. There we go. We have some big text and we have some little text on that page. We are elite coders now. So this is an example of a file on my computer, but there are lots of different files that you might have that are related to a website. There's HTML files like the one that I just made. These are what the browser reads to basically have the structure of everything. There's CSS files. We're not really going to deal with that in this class. But this styles things for aesthetics. So if you see something with like a lot of color, typically you're using a cascading style sheet. And then there's JS files. These are JavaScript files. These are scripting files that make it a dynamic web page. So if you click on something and it changes or loads in new information, that's typically a file that you might use. You have image files, and I'm skipping over a lot because there just is a lot. So let's just do some simple things for fun now. Here's the idea that I have for the project in this class. It's a choose your own adventure style game. And in this choose your own adventure style game, have you seen this before? Have you ever read a book? And somewhere in the book it says, this is where you are. You are here. What should you do? And then it tells you, you can change. You can decide to go to page 11 or you can decide to go to page 12. And this is a way that you can try to like beat a kind of pre-scripted game. Very, very innovative. Very cool. Yeah. We're going to do something just like that, but instead we're going to make our own hypertext book. And we're going to have all of these different web pages. I'm going to do this live now. And if you're like, you know, if you want to skip this part for now, it's okay. You can just kind of fast forward a little bit. But this is how we're going to try to structure this. But before we do that, we're going to look a little bit about the tags that I was just showing you here, right? And in HTML, this is the language. These tag elements, they're kind of like paint on a palette, and you use them to create something. For example, we have this HTML, which is always on the outside of all of the pages that you will make that have an HTML file extension. Then we have another thing called a header, which we're not really going to even do today, where you could do things like you could set the title, you could edit some of the metadata of the web page. Then we have the body. These are the things that you're asking the browser to actually render, the things that actually get shown on the page. The other main ones are the anchor text. So there's like an A start, there's an href, and you would put a URL right here, which is like the address of the server resource. Then you would put the link that is clickable between that, and then have another, what I would call a closed tag. If you look closely, these are, that's a less than symbol, and that's a greater than symbol. These are by your comma and period keys on your keyboard. Then there's a bunch of text tag, H1, H2, H3. These get progressively smaller as you go down. I think it goes up to H5. P for paragraph, B for bold, I for italics, BR for break return, maybe. It creates a new line, and it's kind of hacky, not really the most elegant thing in most web developers' eyes. Tags are often nested. That means you have a tag here and a tag here, and then a close tag here and a close tag here. So for every open parenthesis, close parenthesis tag that you have, there should be another one that matches it somewhere else. Okay, we're gonna update my video. Okay, so yeah, so that's how these tag things work. Most modern pages use some kind of a framework like Bootstrap or something else where they have all of these elements kind of pre-planned ahead of time. That is what a lot of them do. Okay, so in our situation, we are going to have some pages here. And each one of these pages is going to be its own HTML file, right? And so I'll make each of these files first, and then they'll be clickable. We'll have some kind of a small storyline here, which I will do in just a minute here. And basically my thought is that you can start, and then you can click on whether you want to eat breakfast or stay hungry. Then both of these paths bring you back to school. Then at school, you can either skip your test or you can take your math test. And if you take your math test, then you get to win. But if you skip your math test, then you lose. And whether you win or lose, you have an opportunity to click start again and start that whole process over. Okay, we almost have a start down, so I'm going to define that here. Okay, so here's my idea. I am going to start by making each one of these items as their own thing, but before I do that, I'm going to just have a common thing and then copy them all. So I'll stay in my test.html, which I already have up here. Instead, I'm going to say start here. And then I'm going to have a couple of texts down here. One is going to say, go eat breakfast. And I'm actually going to add another thing that says something like, you are in control. What do you want to do? And then it'll give you a couple of choices maybe. One will be go eat breakfast. And one will be go just stay hungry. Now, if I save this and then I refresh this, now I have this information. And what I don't have yet is a way to click on anything. So I'm going to go back. I'm going to add that now. So what we're going to use is called an href, A-H-R-E-F. And so I'm going to do that now. I'm going to say a href equals like that. And then if I close this tag here, I'm going to move it over. And so now what will happen is go will not be underlined. This dot will not be underlined. Only eat breakfast will be underlined. And if I refresh that page, it says eat breakfast. But if I click there, nothing happens. And nothing happens because I have the wrong URL. So because I'm in the same kind of folder right here, I'm allowed to just say the other HTML file. So here I will say breakfast. So I'll have a breakfast.html file. And I'm going to go ahead and create that one next. And I'm going to do that by just copying this file and pasting it. And then if I click and hold on that, it will let me rename it, and I'll call it breakfast. But now I can just click and drag this into my notepad and change it. Now it's going to be called breakfast. And then instead of doing anything else, I have to go to school. So we could say, get on the bus. And that's going to be our hyperlink. With a full belly. And inside of our test, instead of saying, and so if I do that now, I'll save that. I'll refresh it. Then if I hit go eat breakfast, you notice that this is blue. It's because it hasn't been clicked yet. Now if I click eat breakfast, then I'm at breakfast. It says you are in control. What do you want to do? And I could click get on the bus with a full belly, but it doesn't exist yet. So I may end up speeding up the rest, but basically it's going to stay pretty much the same. What I'll do is I'll add another href here to test. Actually, breakfast here shouldn't say this now. And here, instead of just stay hungry, I'm going to put in that href here. And it's the same one, so I don't actually have to change it. And now I need a, instead of school here, I'm going to say hungry. And I'm going to copy breakfast with Control C and Control V. That's another way that you can do it. And then I will say hungry instead. And inside of hungry, I can edit that file. I'm going to say hungry. You are in control. Get on the bus. But you are a little grumpy. Okay, so now I'm going to go ahead and close test here. I'm going to rename it, start. Well, let's see. Let's try the good path, and then we'll try the bad path. So first we're going to eat breakfast. And we get on the bus with a full belly. That's great. So I'm going to click on that. Then we could either play around or take a test for our math class. So we're going to take the test. We're going to do the good path this way. So you took it. You're in control. What do you want to do? Let's go home and see what happens. You're at home and know you did well today. Hey, there we go. Now we're going to restart. Instead of eating breakfast, we're just going to stay hungry. We get on the bus, but we're a little bit grumpy. Now we're going to, instead of taking the test, we're going to play around. And we're going to go home to face the music. And now you're home, but think you might have forgotten something. What did I forget to do today? Oh, it might be that math test that we just talked about. And so you can actually go through many different permutations here. And I think I'm going to try to put, I don't know, maybe I'll try to publish this up for next time or something. I don't know if I'll do that this time, but it might be in the links. We're going to take a look here and just kind of continue. So, what happened there, right? So we made this structure, we made each one of these things become its own kind of game thing, and we took a couple of paths. Our first path was the good path. So we started, we ate breakfast, we went to school, we did our math test, and then we won, right? The second time that we did this, we decided not to eat because we just didn't want to do it. We went to school, we skipped our test, and we lost. That's the game. That's it. That's hypertext. And this was like a super revolutionary idea at the time. And on things like an Apple II, you had a program that would work on your own computer called HyperCard, where you could do stuff like that, and you could click on things and get places and have media. Really just mind blown kind of stuff here. So how did we do this? Basically, we just use very basic HTML files. We use this save and edit from Notepad, right? We did that. And then I saved it on my own computer. I might have put it on a thumb drive instead. I tested it locally with the Chrome browser. I started with one and I just kept refreshing the pages, and as I went. And then at the very end, I allowed the player to restart. And, you know, I could add more details later. I could add pictures, whatever. And so this is just only exists on my computer at this moment because I just made it. I could publish it someplace. I could put it on a website. And maybe we'll go over some of that. Maybe we won't in this class. Other improvements could be adding in better text, more poetic language, better narrative pictures, make it more like an actual book, or maybe making additional possible paths so the game isn't just so stinking easy. Okay, other things that we have not really covered about the internet yet. We have something called a domain, right? The domain is created by ICANN. This is who you have to go through, and usually you would go through like a DNS registrar to actually be able to do that. An example of a domain is CNN.com. An example of a URL might be CNN.com like today. That adds a little bit extra. You used to have to do things like have a www dot, HTTPS, but it kind of goes over that a little bit in that 90s video that I'm asking you to read. Other things that we haven't talked about, internet service providers. There was a big one called AOL back in the day. And they would give you internet. We have an internet service provider here that lets me have internet. Then we have IP addresses. These are things like 192.168.1.1. This is an example of like a local IP address. It's four bytes that go from like 0 to 255. And they also have an IPv6, which you don't care about. It's okay. This is basically like every single computer was thought to maybe have an IP address. And this is how you could access things like a server. And what ICANN could help do for you would be to take something like a website like CNN.com and add a DNS record that would give you basically CNN.com actually goes to some other IP address. That's the point of it. And so this let it be where you could just type in something that seemed like it should exist on the internet, and usually it kind of does. Other terminology we haven't talked about yet are hosts and clients. Hosts basically have all the files, and clients try to get the files. It's an oversimplification, but it's one that we are going to live with for today. All right, so the internet. Back in the 90s, you might use something like Yahoo categories or AOL to surf the internet. You'd have all of these different channels, and this content was so great and fun, and any content that was new was just like magnificent because we were content starved in the 90s. At some point, there was so much content on the internet that you just had to take a different approach. What was that approach? Well, it was search engines. You had this rise of search engines in the mid-90s, one of them being Alta Vista, which is pictured here. How would that work? Well, first you would buy a bunch of servers. You would scan all the domains, right? Domains like CNN.com or mycoolwebsite.com. You would download these HTML files like the ones that we just made, and then you'd see what it linked up to. So basically, if it went to this new thing that we had here, the start, eventually it would branch out and find all of the different connections and all the places where we had an actual web page. It would save that, add it to a database, and eventually make it useful for some kind of search. This is probably actually what it looked like. It's not even pixelated. We just didn't have that many pixels back then. But you can see here, it basically serves as a kind of yellow pages, which you don't know what that is. Yellow pages used to be in phone books, and now they were on the internet. They were stuck in this metaphor thing. This is a browser called Netscape Navigator. This was before Internet Explorer even. It's a very old client, mid-90s. I used this one. Internet, too. So how would web crawlers work? Well, they would start looking at all the stuff that we made. It would start at this start thing and breakfast and collect them all and add them together. And this was really helpful because it meant you could find something without having to browse it specifically. Like you could just look something up if you knew what you were looking for or had a vague idea about it. Searching. Searching requires something called a query. This is the part that you type in. It also gives you something back after you search called search results. Now, at this point, a search result takes about, 0.78 seconds to actually perform and get back to you. But a long time ago, maybe it took 10 seconds or 15 seconds. And colloquially, this is just called Googling. Can you Google this? Can you search for this? But there's different kinds of search, and I'm going to go over them. There is Boolean search, ranked search, page rank, and I'm going to call it modern search. And I'll talk about each of these as we go. And yeah, so Boolean searches, basically they have negative and positive keywords. You'd find them more often in like a database context. It usually gives you exact results. This is still used in places like a local auto shop probably. We have ranked results. These give you keywords gives you information based on the ranking of the things. But it kind of had some issues, and I'll go over that soon here. So, for example, let's assume that we have all these documents about recipes, and our query would be for sugar. In a Boolean search, it would return 5 of these web pages, which are just sentences in this case. Why? Well, because there's the keyword sugar here. There is the keyword sugar here, the keyword sugar here, the keyword sugar here. It's not on these things that aren't bolded right now. The other place that you find it here is where it says sugar right here. And so there's 1, 2, 3, 4, 5 different documents where it actually includes the word sugar. But what if you modified this? What if on the next time that you did this, you took out the words egg and you took out the words cocoa? Well, this has cocoa in it, so we're taking that out of it. And this has the word cocoa in it, so we're also getting rid of that one. And so the rest of the 3 you would still keep. This is one of the techniques that would be used for what you call a Boolean search. Instead, I'm going to try to compare these things using these other kinds of searches. We're all going to search for chocolate chip. Now, chocolate chip would basically become interpreted. Chip would be interpreted as 2 different keywords. And if you did a Boolean search, then this would be the only thing that included it because it has both chocolate and chip in the search query. However, if you did a ranked search query instead, you would end up with more, because while this one includes chocolate and chips, let's say that gives it 2 points because it has both of those words. Well, maybe it has 4 points because it has all of those words or one of those words a couple of times, whereas this one has the word chocolate in it only 1 time, and so it only has 2 points. Basically, what a ranked search algorithm does is it looks at the different keywords and tries to assign a score to all of the different documents. So these might all be zeros. This could be a 2. This could be a 4, for example. And hopefully what that gives you is the most relevant things. So not only one of the words, but the most relevant words. You might guess that there is a big issue that this ended up creating. This issue was called spam. Spam is basically unwanted stuff from the internet that is created by people who, people who just want to make money. So it used to be that if you were looking for a recipe like this, it would just include all the different words that it could possibly think of and some kind of a garbage text. And at the end, it would say something like, buy this. This is something that was very common in the, in the 90s and the early 2000s as well. Now, if we added another word to this, we might re-rank some of the things that are there. So whereas before we didn't have the word cocoa, now we have the word cocoa powder, and cocoa maybe happens a lot less than some of these other things. And so now this particular document has even more points and bubbles up to the top. It really worked surprisingly well. Now, let's say that we also have something called PageRank, and it turns out that this document is from a better web page. Maybe this one is from like Wikipedia, and this one is from like spamking.com. Well, in that case, basically PageRank was a way to put the thumb on the scale and find the more authoritative things. How did it find authoritative things? Well, we'll talk about that in a minute. And then we also have this modern way that people do search. And in the modern way that we do search, the issue is that it does all of the things that old search engines used to do, but it additionally has some filters, and that comes with some benefits to it. For example, some of the keywords are more soft. So instead of saying, chocolate and cocoa might be a lot closer to each other. And so you could search for either chocolate or cocoa and get more or less the same kind of result for that. These are some of the issues that that appeared for all of that here. So Yeah, we'll talk about that in our discussion, I hope. Okay, what made Google so great? Well, in 1998-ish, Larry Page and Sergey Brin created PageRank. They used this random surfer model. They add the processing trick to basically say, hey, this internet is awesome, but it's got so much garbage in it. How do we find the good stuff? And they figured it out. And here's an example of, this looks like it's 1996, the things that were at the top. The things that had some of the best PageRank included Netscape Navigator. Netscape Navigator, this is like a browser. This was like the Chrome of 1996, and it was amazing, and everybody loved it, and I still kind of miss it. It also had a couple of other things. It had CERN. All the nerds who did physics had web pages on CERN. It had Yahoo, which had come out, I think, in 95. This is a search engine. Maybe you know somebody that has an email at Yahoo Mail. Magellan, I don't know what that is. I think it's a search engine. Lycos is definitely a search engine. This is basically Tim Berners-Lee's website, which defined what HTML actually is. Yeah. So combined with PageRank and the rest of the search ranking kind of techniques they were using, it just started working well. You could search something and you could find it, and it wouldn't be the worst thing, and be able to get away from the spam pretty much get away from the spam. And how did they do this? They did this using a random surfer model, and basically the random surfer model assumes that you have a collection of all the different websites and all the different connections to them. And maybe there's something that has a lot more connections to it. I'm going to draw it a little bit bigger. And maybe there's something that has slightly less connections to it. So basically the idea is that the more links that are directed to a particular website, let's say that this is CERN, the more authoritative that website is. And so every time you ended up on a web page, it was based on having been close to that web page. This was called the random surfer model, and it just assumed that you basically had a robot. And every time the robot would look at a website, and they would have a list of links that they might click inside of that website, just like that game that we made, it would just randomly pick them. But it turns out that if you do that and you have a random process for clicking links within pages, eventually you end up kind of understanding this macroscopic, this larger version of what the internet actually is. Which is what we're going to be talking about now. Somewhere in the year 2000, some authors created this thing talking about the graph structure of the web. I really like this quote that they had in this paper where they say, in a sense, the web is much like a complicated organism. It's like an actual creature in which the local structure meaning a web page at a microscopic level, that was where we just were, right? Things like these tags looks very regular like a biological cell, but the global structure, that is the bigger, larger structure, exhibits interesting morphological structure, body and limbs. This is kind of just a fancy way of saying, yeah, we made a picture. And this is the picture that they made right here. And we'll talk about it here in a minute. Therefore, while it might be tempting to draw conclusions about the structure of the web graph from a local picture of it, such a conclusion might be misleading. What is this saying? What are they trying to tell you? They're trying to say that it's hard to see what the internet is looking at it one web page at a time. Instead, you have to look at all the links and where they point to. And that is how they made this this graph here. And in this graph, at the time, there were about 200 million websites, and they think they had all of it. And in the middle, you had what they called the strongly connected mega web node. Maybe I'm calling it that. This is the strongly connected components, where all the websites you could get if you had a random surfer and he was right here, you knew that eventually he could travel all the way to there. You also had disconnected components. These were like little tiny bits of isolated islands on the internet. Pause the game. So we had this big connected components. We had lots of different connected components. And then they had something called end nodes. And here, these were places that didn't actually have very many outgoing nodes. That basically all of these, the strongly connected components didn't talk to it. They didn't connect to it. So no random surfer could get over here, but they could start here and they could get here. A random surfer could start here and get here eventually. In contrast, these strongly connected nodes sometimes would point out here, where a surfer could go from here to this out place. This was things like corporate websites, and the corporate websites would have like internal documents that they didn't want the rest of the world to see. Maybe it's like an employee portal. Then you also had these tendrils. Some of these tendrils, they thought about them like arms on an octopus. They would point out to some place and they would be in this million nodes structure thing. And some of them would have tendrils that pointed in to this outgoing place that came from places like a workplace where you didn't actually have, And then you had tubes that would connect from over here all the way to over here. And it's just this big mass of things. And they're like, whoa, this is way, way, way more complicated than we thought it would be. And I'd have to read the paper a little bit closer to really understand exactly what they expected. But this is a paper from Alta Vista, huge search engine at the time, IBM, still a big company, and Compaq. I don't know how big that company is now. But these people who wrote this paper in 2000 or 1999, they definitely knew what they were talking about. Okay, we are going to talk about homework briefly here. Okay, homework. For homework, we are going to be discussing a few things. That video that I hope everybody has actually read now, or watched rather, on the old web. We're going to be looking at the Wikipedia Surfing Report, so you should already have this piece of paper. Hopefully you have that ready to go. We're going to look at search engines. So we're going to be talking about this Wikipedia Surfing Report. If you lost yours, I'll have a link in the description of this video. And we're just going to talk about search engines, but you don't need to prepare for that at all. For your homework next week, if you're in the high school version of this class, basically if you're over, let's say 12 and over, try to figure out how to do a similar thing to what I did, but just one page of HTML. You can watch this video while you do it and let me know whether or not you're able to do it. In the end, basically we'll have this main project that will include a few different iterations of this. So I'll put a little bit more HTML in every time that we are actually doing this class. And that's it.